right? It's not just, well, I know things, yes, but that knowing things lets you understand things in a different way. So I'll share this story with you. That's a good example of this, and it features your grandfather very heavily. Okay? So when I was, 12 or 13, I had a paper route. So for those of you who don't know what a paper route was, that was kids used to get a couple of bucks to take papers and drive them on their bicycle and ride them around and drop them off in places. And so I had, you'd go and you'd do this both, uphill both ways, quite literally kind of thing, dragging these papers around, and you deliver them. You get some money. And after a while, I'd built up a bit of money, and my dad asked me, so what are you going to do with that? And I thought, oh, geez, what am I going to do with this? I guess I've got money now. I lived in suburbia at a time when there was no online purchasing. There was none of that, right? If you wanted something, you got on your bike and you rode 3 miles, and maybe you could get a candy bar. Woohoo. So I had a fair amount of money. And I said, well, you know what I really would like? I'd love a telescope, a really good telescope. So, my father, Grandpa was like, right? He heard that, said, all right, he needs to research this. Yeah. Now he was not necessarily a science guy. He worked in engineering, worked in computers all his life. He loved watching the nature shows, but he wasn't like a big into science kind of guy. But he went to the library, pulled out the microfiche, pulled articles, researched everything you could about how, where, what, how do you buy a telescope, right? To make sure we buy it right. If we're going to buy a telescope, we're going to do it right. And so he collects all this information. He talks to people he works with. He makes phone calls, because you had to in that day, right? He had to make a phone call, use this phone book to find where people were. And he pulled this information together. And one day after dinner, he says, okay, so I've looked at all this stuff, and it says one of the things we should do is we need to go see an amateur astronomy group, because they can help you figure out what kind of telescope. They might have a used one for sale, yada, yada, yada. And he found one like halfway across the state. So after dinner, on a school night, we get in the car and we drive all the way out to this observatory where the Amateur Astronomers, Inc. of New Jersey were having their meeting. And they have a meeting, some business meeting, which is kind of boring, and someone shows a slideshow. And then they say, okay, so now we're going to do some observing, and they go up to the telescope. Okay, this is a 26-inch reflecting telescope. This is a massive telescope. The only telescope I had ever seen before was the toy one I have. It's about 1 inch in diameter. It's a metal tube. Here's this amazing thing. And say, okay, we're going to look at the Ring Nebula. Okay, so, all right, science lesson. And here's the difference, right? So this is, and it's an important piece. So the Ring Nebula is what's called a planetary nebula. It's got nothing to do with planets, but it's what happens to stars like our sun at the end of their life. So a star normally is this battle of two forces, right? Stars are massive, massive, massive. Like there's I think 330,000 times the mass of the Earth is the mass of the sun. Wow. And all that mass is a lot of gravity, and it crushes the star. It's trying to crush the star into as small a space as possible. So as it crushes all this hydrogen, which is most what the star is about, in the center, it gets denser and denser and denser. And the denser you make something, the hotter it gets. The more you squeeze it together, the hotter it gets. And it gets so hot eventually that hydrogen atoms start colliding with each other with such force that they fuse and turn into helium. And when they fuse and turn into helium, they release an enormous amount of extra energy, which heats up the core more, which means more hydrogen atoms start colliding, releasing more energy. And you start this fusion reaction, this chain fusion reaction, which basically creates, if you will, a nuclear bomb, a fusion reaction bomb in the center of the star that's trying to blow it apart. Wow. So you got these two forces, the gravity trying to crush it, and the force of the core of these explosions trying to blow it apart. And right now, luckily, our sun is balanced. Nothing's going on.
Thank God on that.
Right, which is all good.
Yeah.
So we got this wonderful sun that does so much for us. But eventually, the star uses up most of the hydrogen inside the core. And then it can't create as much fusion reaction to support the gravity, and gravity starts to crush the core. Yeah. It starts to crush it. Of course, as it crushes, it gets hotter and hotter. And eventually it gets hot enough to start a new kind of burning, a new kind of reaction with hydrogen and helium together, and helium and all sorts of other. It gets really complicated quick. And that starts a new kind of fusion reaction. And it gets complicated. It's about shells and all sorts of other things. But basically what happens at some point is that this crushing of gravity starts this new kind of fusion reaction that actually causes the star to grow. It starts beating gravity, and it grows and grows and grows and grows and grows and grows. When I say it grows, when our star hits that point, it will grow to engulf the Earth and possibly even Mars. It becomes this red supergiant. And you can actually see a red supergiant. If you ever look at Orion's shoulder, the high shoulder, is this red star called Betelgeuse, which is a red giant star. If you put that in place of our sun, it would go all the way out between Mars and Jupiter.
That big?
That big.
Oh my
hundreds
God.
of miles hundreds of millions of miles in diameter. So it's this huge, huge space that it gets out there. And it gets bigger and bigger and bigger. Meanwhile, at the core, the core is also, so eventually it gets to a point where it can't get any bigger, and gravity starts squeezing the core again. The problem is there's not enough material left because it's gotten so big at the core to start a new set of fusion reactions. It gets hotter and hotter, but it can't fuse anymore. So all that material that's been expanded outside the star, the gravity's too weak now to hold it in, just starts drifting away. And what you're left is at the center of this star is this core, eventually that blows off all the material around it. This just sort of burning ember of a star. That's all that's left. Tiny, dense, very, very hot, but no longer fusion reactions, and hundreds of millions of miles of debris. This 200 million miles probably in diameter gas field. The cool thing is, because that star is still hot, it's still glowing. And the radiation that comes off of it hits these gas particles, this debris, this giant debris field, and causes them to glow in reds and greens and blues. And so what you get is a planetary nebula. It's this giant, massive gas field, glowing gas field with this tiny dead ember of a star at the center. And that's what the Ring Nebula is.
Yeah.
So I'm now looking through this telescope, and there it is. There's that tiny dead ember of the star. There's this hundreds of millions of miles of glowing gas that's the result of fusion reactions at the center of the star that creates all sorts of cool stuff. And I'm just like in awe. This is just so cool. And eventually I hear, right, time for me to move out of the way. So I pull myself away from the telescope. I move to the side. And my dad, your grandfather, leans down, and Grandpa was tall. He's a big guy. He's a tall guy, 6'4" or something. So he bends all the way down to look in this. He looks through the telescope eyepiece, and then looks up and looks past the telescope into the sky, right, as if he's going to say, "Look, what?" And looks down at this thing. He 2 seconds. He walks over to me and goes, "What?" It was a fuzzy dot with another dot in the middle of it. Like, oh. No, it's, fusion reactions and pulses and hydrogen burning and equilibrium equations. And tiny dot with a fuzzy dot in the middle. That's what he saw. Now, the thing is, when you look through a telescope from the Earth at the Ring Nebula, what you see is a fuzzy dot with a dot in the center. That's what he saw. That's what you would see if you look at it. I saw all the rest of it. Right, because I read about it, I knew about it, I had a picture and a model of what that was, and I could see what that fuzzy dot meant. I could see all these different things happening in this dot, from the shape of it to the colors, all those things. Well, it's not even colors, but the way of looking at it. And so I could see something completely different than he did. And that's the cool thing about science. And the cool thing I realized later is, right, so there's Grandpa, on a school night doing all this research, driving me out to this place to look at a fuzzy dot.
Yeah.
Right? And he's not getting it. But that was such an enormous gift, right? Because even though it was something he didn't understand, doing that meant this is something of value, that this was worth his time to do, even though he didn't necessarily get it. And that was huge for me, right? It's a huge, huge thing to see. I get a parent taking that kind of interest and putting that effort into something that they don't get. And that's sort of that creates that sense of, oh, this is something worthwhile. It's meaningful. It's not just some trivial thing. Because he could have said, okay, it's a fuzzy dot. This is stupid. Don't do this no more.
Yeah, makes no sense.
He didn't, right? It doesn't. But for me, he saw the interest I had in it, and he supported that, and that really, made a huge difference in the kind of trajectory that I took. So making the shift from science to helping people have those experiences, seeing those fuzzy dots for the amazing things that they are, and encouraging folks who have that passion to go into that, that's just an awesome thing.